This is problem 2.5.23. It is an optimization problem. Now the student that asked about this one was trying to figure out an easier way to simplify this problem because it was just a lot of algebra and the pi kind of throws everything off as well. I don't think I actually have an easier way to simplify this. My page of work was very long and drawn out as well, but I'll go through and help you simplify it. So we have this Norman window. Okay. It looks like a rectangle with a semicircle on top. We know that the perimeter is 14 feet. That kind of constrains us. It limits how big the window can be. But with that constraint, we're trying to maximize the area. Now to do this, I split it up into two pieces. So I did the rectangle part and the circle part. This just makes it easier for me to visualize. And I'm going to go through and use what I know about area and perimeter of shapes to say, okay, my perimeter is supposed to be 14 feet. Let's see what it would be. So perimeter of this rectangle, I need h, the 2x, and the h. I don't need the top, so just h plus 2x. Plus the perimeter of the circle. Now usually circle has a perimeter of 2 pi r. So 2 times pi times the radius, which is x. But we only have half a circle, so we'll divide that by 2. And area of a rectangle is length times height, so h times 2x, plus the area of this semicircle. Area of a circle would usually be pi times the radius squared, so pi r squared. But we only have half a circle, so divide it by 2. This would be my constraint equation. It constrains how big the window can be. This is my objective equation because I wish to find the maximum. So let's go through our perimeter and let's pick one variable to solve for to plug into the area. It doesn't matter which one you solve for. I'm going to solve for h just because it only shows up once, so it seems a little bit simpler. So again, looking at our perimeter, I'm just going to simplify what we had up above. So 14 equals 2h plus 2x plus pi x. To solve for h, I would take 14 minus 2x minus pi x and divide by 2. This is h. I'm not going to worry about simplifying it too much. I'm going to plug it into my area equation. Now once again, since we can't see it, I'll write it down quickly. My area was 2x times h plus pi x squared over 2. So if I plug in h, this is 2x times 14 minus 2x minus pi x all over 2 plus pi x squared over 2. Now you can simplify this to varying degrees. I'm not going to try and factor out this pi and the 2 and try and factor out the x. That makes it more complicated for me, but I am going to expand and multiply the x through so I can take the derivative easily. So my 2's cancel, and I have 14x minus 2x squared minus pi x squared plus pi x squared over 2. So this is 14x Now at this point I probably will go ahead, actually I think that will make it more difficult for you. Let's take the derivative before we simplify more. So the area prime, take the derivative, is going to be 14 minus 2 times 2x once I take the derivative, minus pi times 2x plus pi over 2 times 2x, since the derivative of x squared is 2x. So this is 14 minus 4x minus 2 pi x plus pi x. Set it equal to 0. So 0 equals 14 minus 4x minus 2 pi x plus pi x. We're trying to solve for x. So I'm going to move 14, so negative 14, and I'm going to factor out the x. So we're going to have a minus 4 minus 2 pi plus pi times x. And instead of negative 2 pi plus pi, let's just change that to negative pi. And divide, so x equals negative 14 over negative 4 minus pi. Or let's simplify that to divide top and bottom by negative, so positive 14 over 4 plus pi. And everything, and if you look back at the book, the units were feet. So my final answer is that x should be 14 over 4 plus pi feet to maximize the area of the window.